Hey guys, and welcome back to Study Journey. It's Mary and I'm back with another AMC 10 Problem of the Week video. And for this week's video, it's going to be about being able to use arithmetic progressions or sequences. So without further ado, let's get on with the video. This is AMC 10A Problem 10 of the year 2016. A rug is made with three different colors as shown. The area of the three differently colored regions form an arithmetic progression. The inner rectangle is 1 foot wide and each of the two shaded regions is 1 foot wide on each side. What is the length in feet of the inner rectangle? And your answers are 1, 2, 4, 6, and 8. So let's mark out some keywords. Well, this is made with three different colored regions and they form an arithmetic progression. So the inner rectangle is 1 foot wide and each of the two shaded regions is 1 foot wide on each side. And it is asking you the length of the inner rectangle. To solve this, we can first let the length of the inner rectangle be x. And that is what we will be trying to solve. So how do we solve this? Well, we can list a few equations and find the relationship between them to solve this problem. So let's see. We named the length of the inner rectangle x, so this is x and this is 1. So the area of the smallest rectangle would be x times 1, which equals x. And then the area of the second rectangle, so this is the area of the first, the area of the second rectangle would be, well, we know that it is 1 foot on each side, so the length would be x plus 2. And then times the height, because we know this is 1 and it is 1 foot on each side, and that is 3. So it's x plus 2 times 3. And we can simplify that as 3x plus 6. Well, this is the area of the whole rectangle. To find the area of the shaded region, we have to subtract the red area. So the area of the second shaded region, this would be 3x plus 6, which is the area of this second rectangle. And then you subtract the area of the inner rectangle, and then we get 2x plus 6. This is the area of the second shaded region. This is the first, so let's find the third. Well, to find the area of the third shaded region, we have to find the area of the third rectangle and then subtract the middle rectangle. Since this length is x plus 2, then we know that this length would be the x plus 2, and then you add the 2 of the sides. So that would be x plus 4. And then the width would be the second rectangle width is 3, and then you add 2. So that would be 5. 5x plus 20 is the area of the third rectangle. Now we just have to subtract the area of the second rectangle. So the area of the second rectangle, as we can tell, is 3x plus 6. Remember, this is the area of the shaded region after we subtracted the red. We can subtract the second rectangle from the third. 5x plus 20 minus, simplify, and we get 2x plus 14. Now that is the area of the third shaded region. This is the area of the purple region. So this is the purple, this is the green, and this is the red. Now it says that the area of the shaded regions, which is red, green, and purple, they form an arithmetic progression. So first we have to know what an arithmetic progression is. So an arithmetic progression, if you see my other video, it is also known as arithmetic sequence, and this is just a sequence of numbers such that the difference between the consecutive terms is constant. So this would usually be written as a plus d, where d is a common difference or the number that is added each time. So it would be a plus 2d, a plus 3d, etc. For example, it could be 2, 4, 6, 8, where the common difference would be 2. So 2, and then 2 plus 2 is 4, and then 2 plus 2 times 2 is 6, and then 2 plus 3 times 2 is 8. And we know that these three areas form an arithmetic progression. So that means the x plus a certain number, or the common difference d, would equal the second shaded area. And the second shaded area plus a common difference d would equal the third shaded area. So here is the key part. We don't want to add an extra variable d into this equation. So how can we make it so that we can represent what we are trying to say about the common difference without using the variable d? Well, we know the area of the green minus the area of the red. That is the common difference. And the common difference is also same to the next consecutive number, which is this shaded region minus this shaded region. So what do I mean by that? Well, the area of the second shaded region, and the first is a arithmetic sequence. If we write it with the d, it would be x plus d equals 2x plus 6. And then here, 2x plus 6 plus d equals 2x plus 14. So we would subtract these two equations, and we would get x minus 2x plus 6 equals 2x plus 6 minus 2x plus 14. Now we can simplify. And then we can see that x equals 2. The answer would be 2. Now we can obviously check our answer by plugging it in and seeing if it matches. So let's try that. Well, the area of the red would be 2. The area of the green shaded region would be 2 times 2 plus 6. And which would be 2 times 2 is 4 plus 6 is 10. Third would be 2 times 2 plus 14. 2 times 2 is 4 plus 14 is 18. 2 to 10 you add 8. 10 to 18 you add 8. So this is an arithmetic sequence with the common difference of 8. So looking at our answer, we can tell that the answer would be B, 2.